Right, this is section 5.2. Today we're going to be talking about parallel and perpendicular lines. So by definition, two parallel lines are going to be two lines in a plane that never meet or cross, right? So if we've got two lines that are just going to continue on being the same distance apart forever and ever and ever in a single plane, then they're going to be parallel. If your two lines intersect at 90-degree angle, then that would be a perpendicular line. And then a transversal is a line that intersects any two or more lines. So this would be a transversal. If we were to have a perpendicular here, and by looking at it, you wouldn't be able to tell that that is perpendicular. You would either need to be told that it's perpendicular, or it's going to have this little box on it. That will also indicate that it is perpendicular. So you've got parallel, perpendicular, and a transversal is going to be this line right here that intersects two or more lines. So there's some interesting properties that go with transversals and parallel lines. So if you have two lines that are parallel and they are intersected by a transversal line, just like the picture on the previous page, so you've got two parallel lines and a transversal, the acute angles that are formed are going to be congruent. So that's going to be this angle right here and this angle are congruent, which means they're the same size, and this angle are congruent, as well as being congruent to one another. So you could say if this is angle 1 and this is angle 3, that 1 and 3 are congruent, and 1 and 2 are congruent, 2 and 3 are congruent, and 2 and 4 are congruent. So the acute angles are all going to be the same size. All the obtuse angles are congruent to one another. So that would be this one. So I'm going to draw two lines like that because the lines, a single line is going to tell you that all of those are congruent, and the two curved lines tell you that any angle that has a double curved line is going to be congruent. So let's say this one's A, B, C, and D. So we would say that angles A, B, C, and D are all congruent to one another. They're all the obtuse ones. You can also say that any acute angle is supplementary to an obtuse angle. So if you look at these two together, it's easy to see that they're supplementary, that they add up to 180 degrees. But you could also say that angle 2 and angle C are supplementary because they're going to add up to 180 degrees as well. Now, if your transversal is perpendicular, so if you've got these two parallel lines, pretend those are parallel, and your transversal comes out to perpendicular, then that means all of the angles in there are going to be congruent 90-degree angles. So this one's 90, and that one's a 90, and that one's a 90, and this one's a 90, and that's a 90, and a 90, and a 90. So you've got all these 90-degree angles. Which means that they're all congruent to one another. Another way of looking at these parallel lines with their transverses, just to give you the definition, give you some more vocab words to look at when you're describing them, you can talk about alternate interior angles, which I showed you on the previous page. Let me show you again. So alternate means they're on either side of the transverse line, and interior means they're in between the two parallel lines. So an alternate interior angle would be that this one right here and this one right there. They're going to be congruent. The other two alternate interior angles are going to be the obtuse one and this obtuse one, and those are going to be congruent. Alternate exterior lines are going to be on either side of the transverse line, but they're on the outside of the two parallel lines. So alternate exterior is this one and this one, other side of the transverse, and outside of the double line, so it's going to be those two. So those are going to be congruent. The other one is corresponding. So that just means like the on opposite sides of the parallel lines and on the same side as your transverse. So a corresponding angle is going to be this one. Those are going to be congruent. Then you've got this one in here is corresponding to that one. So I'm going to label these A's and these B's. Then you've got this one, and its corresponding is going to be this one right here. And then you've got this one, and its corresponding would be here. So it's like the one that is kind of on the mirror image of it. So on the other parallel line, same side as the transverse. So you alternate interior, alternate exterior, and corresponding. So let's take a look at how this plays out in a problem. So if we have this figure and we know that line R is parallel, that's what this symbol right here means, is parallel to line S. So we know that this line right here is parallel to this line. We want to find the measure of each angle. All right, so I've numbered my angles, so we're going to look for measure of angle 1, 2, 3, 4, 5, 6, and 7. All right, so pretty simply, looking at all the other things, the properties from the last two slides. So if we know the measure of angle of this angle right here is 68, then we can tell that all of the alternate interior and alternate exterior angles are going to be the same. So the alternate, well, this is the corresponding. So it's going to be this one and that one and that one and that one. So this angle 2, angle 4, and angle 6 are all going to be 68 degrees because they have to be congruent, because you've got here, we've got alternate exterior, which is that one and number 6. We've got corresponding, which is that one and 4. And if 4 is corresponding to that and 2 is congruent to 4, then 2 and the measure that is labeled as 68 degrees have to be the same. So the measure of angle 4 has to be 68 degrees, because all the acute angles in this figure are going to be congruent. So angle 3, the way we can figure that out is because those are next to each other, and all acute and obtuse angles are going to add up to be supplementary. So the measure of angle 3 has to be 180 degrees minus 68 degrees because they are supplementary. So measure of angle 3 is going to be, these would add up to 180. So the way you would solve that is to subtract what you know from 180 to get that measure. So the measure of angle 3 is going to be 112 degrees. Now, if measure of angle 3 is 112, and angle 3 and angle 7 are corresponding angles, then the measure of angle 7 has to also be 112 degrees. So I want you to copy down this figure, and you're going to use it to answer questions on the quiz. It just has to do with finding the measure of the angles from line L and line M. All right? And for this, assume that L is parallel to M.